Morning, myself, Dr. Shanmugam. I would like to present my topic is mathematical physics in one part of inverse Laplace transform. See, the mathematical physics, what is that? The branch of science that applies mathematical methods and rigorous mathematical reasoning to solve the problems in physics. It deals with using mathematics to formulate laws, analyze physical systems, and derive solution of physical phenomena. Physical phenomena. So Laplace transform, the explanations and a definition. What is that? Basically, f of t. We have two domain function usually defined for the t, that zero conditions, into the complex frequency domain function f of s. So and where we use that the inverse Laplace transform to simplify solve the differential equation, converts differentiation and integration into the algebraic operations, and widely used physics, engineering, and control systems. So inside the definitions are there and formula also are there. F of s is equal to L of f of t. The integral of infinity to 0. 0 to infinity e, the minus power of minus st f of t into dt. That denotes that is the time, g is the complex variable, and f of s the Laplace transform. The next slide is inverse Laplace transform, the methods and partial fractions. So inverse Laplace transform, what is that? The reverse process. It converts a function from the S domain back into the original time domain forms. So definition, so is there f of s is equal to L of f of t. The inverse Laplace transform, just L inverse of f of s. So these are the where we have to use that, the Laplace domain and the physical times. It helps to obtain the actual time response in the circuit, mathematical system, and power systems. And one more thing, that mathematical inverse Laplace transform, that we have three categories: partial fraction method, standard transform tables, and residue method. So now we'll explain to the partial fractions. So partial fraction is nothing but split complicated rational function into the simpler fractions. So that is the called is subfractions. So in the next slide, they will directly go to the find the problems. Find the problems in the sense inverse Laplace transform s plus 4 divided by s into s minus 1, s squared plus 4. So this problem we have to follow that what are the splitting and what are the steps are there. See, given that split in the fraction is big and complicated, so that work we have to simplify the small and simple fractions. So 1 by s, already s plus 4 is there, now we'll take 1 by s and 1 by s minus 1 and 1 by s by s squared plus 4, and one more thing, 1 by s squared plus 4. This is the simple steps. And again we'll rearrange the steps. We have to follow that second step for the partial fractions method. So s plus 4 divided by s into that s component, so a by s, b by cs minus 1, and c plus d, that we have to name the identified cs plus d divided by s squared plus 4. So 1 by this one, 1 by s squared plus 4, the steps will do the common, that 3 steps. Why in the formation we have to split up of the partial fractions? We need to value of the a, b, c, d. We'll substitute final value for the this s squared values. So now all the terms we have to substitute. S is equal to 0 for the this whole process. So s is equal to 0. What is that? All the places. S plus 4 is there, no? Put 0 plus 4. A minus 1 and 4. Can understand these steps. A minus 1. First A will steps, we will take these 2 steps. So 4 is equal to minus 4a. A is equal to minus 1. So next is s is equal to 1. We have to put it 1. 1 plus 4. This 1 plus 4. Remaining steps is b1. We'll take the b1 and 1 plus b1, 1 plus 4. So now 1 plus 4 is equal to 5. So b normal B. This one 1 plus 4 is equal to 5, 5B. So now B is equal to this 5, this 5 is, it will be cancelled. That is cancel in the sense 5 by 5 is equal to 1. So I will to go to the next slide. Compare the coefficient to find C and D. C in the sense the coefficient of S3. We have all the steps will be equating A plus B plus C. So now that C values we don't know. So that's why we'll conclude that C values, A value have to minus 1 and B value plus 1. We'll substitute the steps. C is equal to 0. Why in the sense this minus 1, this plus 1, it should be cancelled. Next is the coefficient. We'll conclude that yes. So this yes, 1 is equal to, will substitute again. Y in the sense already there s plus 4 is there. So that's why 4a plus 4b minus d. So a values we know, b values we know. So now we'll substitute the a and b values. Finally this minus 4 plus 4 should be cancelled. Remaining 1 is equal to minus d. So now that minus d, that values we did not put like that. So that's why this minus should be go there this side. So d is equal to minus 1. So now we know have all the values. So A value is what is that, B value what is that, C value is what is that, and D value what is that. So now all the values will substitute the first formula. S plus 4 divided by S term and S minus 1 term, S squared term. So S squared name is what is that? Sorry, that value is 1 by minus I. Why in the sense we know that value minus 1. Next is 1 by plus value. So same values. S minus 1. And the next is 1 minus S squared plus 4. Why in the sense C values? It is equal to 0 and D value is also minus 1. So that's why it minus it will comes. So now we'll take Laplace inverse transform. The formula is what is that? Laplace inverse in the sense L power minus 1. So 1 by minus 1 by S is equal to minus 1. 1 by S1 is equal to ET. So 1 by S squared plus 4. So what is that? 1 by 2 sine 2t. All the steps will equating here. See that equating in the sense theory 1 minus minus 1 plus et minus 1 by 2 sine 2t. So now we'll substitute that values is what is that? S plus 4 divided by S into S minus 1 S squared plus 4. The values is minus 1 plus et minus 1 by 2 sine 2t. So these are the final formulas. So now where we are that use for applications and importance and day-to-day life we have to use varieties. See here, Laplace transform help convert complex differential equations into algebraic equations. That makes solving the problems, engineering, physics, mathematics easier and faster. So essential tool is what is that how system respond over time. In the sense we have to usage for this daily day-to-day life applications, electrical circuits, mechanical systems, control systems, and signal processing system. For example, these electrical system predicting how lights, fans, electrical device respond and when switched off on or off. So mechanical also, the vehicle, machines and buildings. Control systems is thermostat, elevators or automatic doors to respond correctly. Signal processing, phones, radios and music systems use these principles to filter signals. Everyday relevance helps engineer design safe and efficient. Ensure electrical devices and appliances work smoothly and used for medical equipment also like ECG and MRI signals. So last is, and thank you for giving me this opportunity for Sunway Institution. So thank you everyone.